Okay, first things first, if you open this worksheet and it does not look like this, it's upside down, you should go to View, and then in View in the PDF, you can rotate it clockwise or counterclockwise. You need to do the same thing twice so that it completely flips around if it doesn't look like this when you open it. Okay, the order of operations. Let's take a look at these. One of the ways that some of you have memorized how to do the order of operations was with PEMDAS. And PEMDAS was parentheses, exponents, multiplying and dividing, and adding and subtracting. And multiplying and dividing was from left to right, and adding and subtracting were from left to right. So in terms of remembering this, that I think is the most common way. Otherwise, you just need to remember. I work on remembering PEMDAS or remembering the exact order of operations. Why do we have the order of operations? Well, we have the order of operations so that we can all get the same answer. We can all be doing the problems exactly the same way. If we didn't do them exactly the same way, then we're going to end up with different answers. Okay? The order of operations allows us to follow a set of rules that get us from point A to point B, as in like a set of directions. So if we all went different ways to get to school, but we didn't follow a map or set of directions to get there, then we would all set up our school in different parts of Albert Lea. Well, we don't want to do that. We want to all get to the same place, whether we're coming from any direction, north, south, east, west, northeast, and so on. So that's what the order of operations allow us to do. They allow us to get to the same place by doing the same things. So number one, we want to look at any parentheses. Okay? And sure, there's parentheses here. So when I do these problems, I'm going to take them off to the side and do them on a separate piece of paper, because there's just not enough room for me to write them on this sheet. And you can take them off to the side over here if you want. You can take them off to the side anywhere that you want to, but I would suggest not doing them in the middle of the sheet. Okay, so you should do the problems on a separate sheet and then put the answers in this set. So I've got 71 times 4. Let's get a new sheet here. 71 times 4. And then plus 2 minus 1, and the 2 minus 1 is in parentheses. So I want to follow PEMDAS, so I start with parentheses. Parentheses, I've got the 2 minus 1, so I've got 71 times 4 plus 2 minus 1 is 1. This is the way that you should do these problems. Go through, do each step. Even though I know that you know that 2 minus 1 is 1, if you don't go and continue putting it and writing everything else exactly the same way that it is, then there's increasing the chances of making a mistake. So now I want to do exponents. There are no exponents. Then I want to do multiplying and dividing from left to right. Well, I've got multiplying right here, 71 times 4. If I do that, 4 times 1 and 4 times 7 is 28. And I'm going to rewrite the plus 1 as if I didn't do anything with it, okay, because I didn't. Now I've got any dividing. There is no dividing. Then I'm looking at adding and subtracting from left to right. Well, here's some adding. 284 plus 1 is 285. Okay, so this is equal to 285. So when I come back here, I'm going to put, I'm going to put my answer of 285 in here. I've got the same problem in number 1 on this side, except that the parentheses are in a different place. And so I need to follow the order of operations, doing the same exact problem, except that I've got the parentheses here. Instead of on the 2 minus 1. So when I do PEMDAS, I start with parentheses. I do 4 plus 2. So I have the 71 times 4 plus 2 is 6, and then minus 1. Now I have adding and multiplying and dividing from left to right. Here's multiplying again. 71 times 6. This time 6 times 1 is 6. 6 times 7 is 42. And then I've still got the minus 1. 426 minus 1 is 425. You can clearly see that we get a different answer by doing this problem in a different way. 425 is what I ended up here. Okay, that's the way that you need to go through each one of these problems. Okay, each one on the left-hand side matches up with the same one on the right-hand side, except that we're doing them in a different order. A couple things. The 2 didn't show up on number 2. Actually, you probably can see it. This is a 2 right here. If you couldn't tell, this is a 2. So it should be 18 plus 7 minus 4 times 2. On the sheet that I have in front of me, it's hard to see, but you can see it on the video here. So going through each of these, make sure you're paying attention to the parentheses are, any exponents that are added in. Let's take a look at number 3, just so that we're all clear about what happens with the exponents. And I'm just going to take a snapshot of this so that I don't rewrite it incorrectly. That was pretty loud. All right, so number 3, this is number 3. I've got 22 plus parenthesis 19 minus 8 parenthesis times 2 squared. So I want to follow PEMDAS, so I start 22 doesn't have anything to do with the parentheses, 19 minus 8 does. Then I want to do exponents. Well, 22 plus 11 doesn't have anything to do with exponents. 2 squared does. Then add it, multiplying and dividing from left to right. I've got 22 plus, those don't have any multiplying in them, but I do have multiplying right here. 11 times 4 is 44. Now I've got adding and subtracting. Add those two together, gives me a 66. So go through and do these problems. The order of operations, it brings us to a direct way for all of us to walk through the problems in the exact same way. The next sheet on here, simplifying expressions by combining similar terms. We don't use the word similar terms, but if you see it, it means the same thing. What we've been using is like terms. Okay? And so simplifying expressions by combining like terms. When I go about trying to combine like terms, I'm just looking for the like terms. So I've got, in number 1, I've got 3 plus 9a minus 6a. Well, I've got 9a and minus 6a. So 9a minus 6a, the 3 is still out front. 9 minus 6, we did this with radicals, so now we're just doing it with the variables. 9 minus 6, when they're the same, we end up with 3a. So then what I want to do is I want to go and I want to look for that answer in the answer bank. Well, if you're going through and you're looking, there is no 3 plus 3a, but you have to remember that thanks to the commutative property, we can arrange these two in a different order. 3 plus 3a is the same thing as 3a plus 3. So that gets us down here to answer C. Okay, so I'm going to put the answer out front there. Then I move on to number 2, 10a plus negative 4a. Okay, they have the same a's. So 10 plus negative 4 is 6a. And then minus 2a, again, still has a's. So 6a minus 2a gives me 4a. Going again, looking for that answer in the answer bank, gives me a 0 here. The next the next one, I've got A's on the outsides here, and I've got a B in the middle. So the A's and the B's don't match. So I'm not adding the whole thing together. I've just got 7A plus 6A, which gives me 13A. And I've got the plus negative 3B. I can either write that as plus negative or minus 3B. We want to take a look and see if we can find 13A minus 3B in the answer bank. And here's an I. And we're just going to continue going through doing finding these like terms, combining like terms, finding the answers in the answer bank. The answers can be repeated, so if you find another C, that's okay. If you find another answer of 4A, you can have O again. We're just answering the question that says a numismatist collects this. And so all the letters are going to be in here. We're just going to put the letters in order so that we come up with what a numismatist is collecting. The next sheet, substitution. Substitution is one of the biggest properties that is going to happen in algebra. You did a lot of this in geometry. You substituted expressions for numbers, numbers for expressions. Same thing is going to happen here. So in this case, I've got x is equal to 4. I'm going to take and I'm going to go 5 times 4. I'm going to substitute that number in. 5 times 4 is equal to 20. Same thing on number 2. I've got 5. When I put that 4 in for that x, I'm going to put it in parentheses on my own. It was put in parentheses in number 1, but in number 2, I'm going to do the same thing. So I'm going to end up with 20. So the directions say to complete the following box questions, then solve the puzzle below. So when I have this 20, I go down to the bottom and I find the 20, and the word was U, and so I'm going to plug a U in there. Then I go on to the next one. I'm going to plug a 7 in for B. So when I plug that 7 in, I'm going to get 2 times 7 plus 7. Well, 2 times 7 is 14. 14 plus 7 is 21. Again, following the order of operations. Okay, multiplying and dividing comes before adding and subtracting. So I have to do the 2 times 7 first. So I end up with a 21. The word is O. If I come down to the bottom, I look for a 21. The word is O. That doesn't mean that I'm done with the problem. I should still continue and do number 8. So B is 7, so I get 4 times 7 minus 3 times 7. 4 times 7, I got multiplying left to right, so that's the first multiplication problem. So 4 times 7 is 28, and then 7 times 3 is 21. 28 minus 21 is a 7. Notice that I didn't get the same answer. I got a 21 and I got a 7. So that means that if there's a 7 down here, I also need to put an O in there. Oh, but it's not. So I move on to 13. Let's move on to 13's fine. Okay, so we'll do m equals 8. So I end up with 8 plus 8. Okay, when I put them in, I want to put them in parentheses. The parentheses aren't actually meaning anything in this problem, so I've got 8 plus 8, which is 16. Let's do the next one. I've got 2 times 8. I'm plugging in for m, plus an 8 that I plugged in. 2 times 8 gives me 16. 16 plus 8 gives me a 24. So I've got 16 and 24 go with the word save. Notice that the 16 is not down here, but the 24 is. Okay, so you don't know which one of the problems is going to result in you having a word down here. So go through, finish this worksheet, plugging in and substituting those numbers. It's an important skill that we have to be able to do in order to move on to functions and relations. And then finally, the last part, where we are translating from words into math. This is a huge skill for us. If you cannot read what your math is asking you, then you cannot really solve it. Okay, so we have to make sure that we can solve these. When I translate this, I'm going to translate this number to be x. Okay, so everywhere that I have the word this number, okay, when this number, 4 times a number, okay, I'm going to put a variable in there. Do you have to choose x? No. You could choose a y, you could use a z. Things that you should not use an I. You should not use an O. I stands for an imaginary number. O looks like a 0. Okay, so you should not choose those. But you can choose almost any other variable. The E is another variable that you should not choose. But if you, in this context, if you just used an X, you should be fine. Then this number is going to mean equals. And again, is. You have to be careful with is. We'll take a look at number 3 after we do number 1. Okay, because here's an is and here's an is. Well, I have to decide which one is actually the equal sign, because one is not and one of them is. Okay, so you have to be careful with just blindly saying that is means equals. Okay? But in most cases, you can jump to that that conclusion. Now I have 3 less than. Well, if I have 3 less than something, that means that I took away 3 from something that I began with. Okay, and so 3 less than actually means minus 3. Okay, and so I'm going to take and I'm going to take 3 less than what I started with. And what I started with was the sum, which is adding, and the things that I'm going to add together are 18 and 24. So when I write those things together, I'm going to take the sum of 18 and 24. I'm going to add those two things together. And then I'm going to take 3 less than that. So whatever answer I get for that, I'm going to take 3 less than that. And that's going to give me what my number is. And now once you've translated it, then you should solve it. Now there's some order of operations here. 18 plus 24. 18 and 24 gives me 30, 42. 42 minus 3 gives me a 39. So my answer here is a 39. Number 2, this number is 14 more than. Again, more than, in order to have something more than something, I have to have something to start with. So I'm actually going to be having a plus 14 at the end of something. And it's at the end of the difference. Difference means subtracting. At the end of a difference between 62 and 12. So I'm going to subtract 62 and 12. So I've got 62 minus 12. And then I'm going to have 14 more than that. So I'm going to add 14 to that answer. And that's what's going to give me the x in this case. So I have 62 minus 12 is 50. 50 plus 14 gives me 64. Now number 3 we kind of talked about before, but here's a little bit of a tricky one. When this number is divided by 3, okay, and so this doesn't say what the answer is. Okay, the first one said this number is, and that that tells us that it equals something. But in number 3 it says when this number is divided by 3. So this number now we're saying that it's being divided by 3. It is, so this one's the equal sign. The number it is going to be equals. So I've got x divided by 3 for my first part. It is 1/3 of the number 5. When you look at this word, there's no reason for that word to be in there. So I've got a number x divided by 3 equals 1/3 of the number 5. So 1/3 of 5 is going to be 1/3 times 5. It's a 3. That's a horrible 3. 1/3 times 5. So again, this is something that you should not clearly be trying to squeeze in on this paper. But let's take that to another sheet. I've got x divided by 3 is equal to 1/3 of the number 5. Well, x divided by 3, if I write this like this, and I write 5 like another fraction, then I can combine. I've got x divided by 3 over here, and I can multiply these two fractions together. 1 times 5 is 5, and 3 times 1 is 3. Well, now there's some logic that goes into this. We can do the math behind it too, but some logic that goes into this. If I've got x's over 3 on the left-hand side, and I've got a 5 over 3 on the right-hand side, then x has to be 5. In order for these two things to be equal, the top part has to be a 5. And so when I look at this, I want to look at and see that this x actually is a 5. I can prove that mathematically because I can multiply by that denominator to get rid of the denominator, and the denominator goes away. Fractions are just big division problems, so if I want to do the opposite of that, I can multiply by that 3. Well, if I multiply by 3 on this side, then the denominator goes away and they cancel, and then I mathematically get that x is equal to 5. Logically, it also was equal to 5 from the first part. So when we look at this, we're going through and we're translating each one of the words so that they come up with an expression or an equation, and then that equation then it needs to be solved in order to get the answer. This is the end of section 1.4. 1.4 dealt with combining like terms, translating words, and doing some order of operations work.